the rest of the notes for today. So this starts with evaluate the logarithm. If necessary, use a calculator and round to 3 decimals. So this is just repeat. This is not like new. Will I need a calculator for the first one? No. What I can do is I can rewrite 32 as a base of 2. What will my exponent be? 5. These cancel. Answer is 5. Next one. Will I need a calculator? Should not need a calculator for this one. So I'm going to write log base 27. I can't change the base, but I can change the big number to a 27. I just have to figure out, how do I take 27 and change it into 3? What exponent will take 27 and change it into 3? 1/3. So those cancel and we get a third for our answer. Next is log 12. So this is the common log, which is a 10. Is there a way to make 12 into a 10? No. So this would be a calculator question. And there is a button that says log. So we just type log 12, enter. You guys typed it so fast you didn't even have time to take out your calculator. And then ln 0.75. That is the same thing as log base e. Does anybody know what e is, by the way? The number? Oh, I mean like the actual number is, it's a number. Yeah. It's like pi. It's like pi, where it's like a long irrational number. It shows up in calculating interest and stuff like that. Anyway, so this is log base e, and this is just like a random number. I won't be able to do this by hand. That is a calculator question. So I'll hit ln 0.75, enter, and we get negative 0.2877. And I just went over how to do that on the last video. So, okay. I think this is the last. Yep, the last thing in the notes for today is inverse properties. Okay. So we've already gone over this. So let's simplify question A that says 10 to the log 4. So this, if I'm writing it bigger, it says 10 to the log 4. So if I have a base of 10 and I have a log, just a log, that is a base of 10. Those are inverses. My answer is 4. And remember, the reason why the 4 becomes big is because we put it in front and we multiply by the properties we went over today. How about question B? Log base 5 of 25 to the x. So this x, I can put in front. That's a property we learned today, or at least we went over today. What can I do with the 25? Make it 5 to the second. Good. So when it's 5 to the second, log base 5 and 5 cancel. The 2 goes to the front. And we get 2x. Any questions about that one? Okay, try them. 4 of them for you to try. Okay, so the first one, this is an exponent. I'm sorry, 8 is a base. And then the exponent is log base 8 of x. And remember, 8 to the log base 8 are inverses. So just x. The second one, log base 7 of 7, inverses, negative 3x. The third one, 64 is 2 to the 6. So 6x is the answer. And number 16, e to the ln, those are inverses. So the answer is 20. Do okay? All right, and then the last thing is these are going to be equations, and we're going to find the inverse of that equation. Now, we did finding inverses in chapter 1, so it's been a while. To find the inverse, the first thing that you do is you switch x and y in the equation. And then we solve for y. Put in function notation if needed. Okay. So those are our steps for finding the inverse of any equation. We're going to just start by switching the x and the y. So the very first equation is a function f of x equals 6 to the x, so there's no y. So I'll put in a y first. Y equals 6 to the x. Now we get a y. So switch x and y, and we get x equals 6 to the y. So I made the inverse by switching the x and the y. But we have to solve this for y. So what is in my way? What is in the way of me having y by itself? The 6. But since y is an exponent, I have to cancel out the base of 6. What cancels a base of 6? Log base 6. So if you listen to the way I'm saying it, so you guys can hear like the correct way of saying these things. Log base 6 of 6 to the y. Those will cancel. We'll get y equals log base 6 of x. So the last step, put in function notation if needed. If it starts in function notation, we should put the answer back into function notation. So I'm just going to write the answer in function notation. The inverse function, you do f inverse of x equals log base 6 of x. All right, so let's just do a few more examples. This one doesn't start in function notation, so I already have y equals. I'm going to switch x and y. X equals ln y plus 3. So this is in logarithmic form. Ln is a natural log. It's in logarithmic form. To get y by itself, we have to cancel out a logarithm. So we have to exponentiate. When you cancel out the logarithms, you're doing exponentiate. So what is going to be my base for both sides? What will cancel out natural log? E. That is correct. So I'm going to do e to the x and e to the ln y plus 3. So I have e to the x equals y plus 3. And then to get y by itself, e to the x minus 3. Okay, next equation. Let's do the inverse, switch x and y. Switch my x and my y. Got x equals log base 2 of y minus 1. We need to get y by itself. It is logarithmic form right now. If it's logarithmic form, I have to exponentiate. What base should I use? Anthony, do you? Excellent. So he's going to move the 1 over. And we're going to do a base of 2. So we got 2 to the x plus 1 equals 2 to the log base 2 of y, and those cancel. Why did I put the answer for the first one in f of x form, but not the next two? Because it started, number 1 started in function notation, where these just started with y. So you're just following whatever the original gives you. All right, question D. So I better put it into y equals 5e to the x. So I can switch my x and my y. X equals 5e to the y. Connor, what should I do first? Divide by what? Yeah. Or multiply by 1/5. I feel like it would look better to multiply by 1/5, but divided by 5 is totally fine also. All right, so now I have e. And then I've got y as an exponent. So we have to think the opposite of exponential is logarithmic. We have to log both sides. What log base should I use? Natural log. Log base e, natural log. So I'm going to do ln to both sides. You know that y can swing around to the front. The ln cancels out the e. So you get y equals ln of 1/5 x. And since this one did start in function notation, I'm going to write my answer back in function notation. F inverse of x equals natural log 1/5 x. Okay, there's 2 student practices. Try them. Yeah. X over 5. Yeah, that'd be okay. Would it be okay if you wrote it as ln x minus ln 5? Could you write it that way, Chris? They're all equivalent. So yes. All right, student practice, you try. You need to get a new. Wait, you have your thing?
It's a locker.
Oh, so you need to go to your locker. How do you feel so far about logarithms? Good. Are they okay? Well, we haven't practiced. I make it look easy, right? Okay, let me go over these answers. So the inverse, we'll start with x equals 4 to the y. This is exponential, so I need to use logarithmic. I need to change it to logarithmic form, log base 4. You notice that they are, one's logarithmic form, one is exponential form. The 4 is the base for both of them. Number 18, x equals ln y minus 5. So the first thing that I need to do, this is logarithmic form, so I have to exponentiate both sides. So I'm going to do e to the x equals e to the ln y minus 5. So get e to the x equals y minus 5. So y is e to the x plus 5. All right, for your assignment, you guys have 2 worksheets, I believe. Oops. So you have the from last week, the rest of that. Well, it's not the rest of the worksheet. There were 2 worksheets on that file. There were just 2 worksheets on the file. So you have the second worksheet. And oopsies. And today you have a second worksheet. Okay. But you saw these go pretty fast. I will tell you that there's, excuse me, a couple challenging questions on this second worksheet. Numbers 1, 2, 3, and 6 are kind of challenging. So definitely ask. I expect questions. If I'm not getting questions, I just feel like you don't care. So I'm expecting questions. If you know you're not going to ask questions if you leave this room, we have 40 minutes. Maybe go look at those first. All right. The first worksheet's not very long, right? The first worksheet, who's got the first one out? Is it like 8 questions or something? It's like really short. Yeah. And then this one. All right. Sounds great.